problem, we can use substitution. We can easily take the solution to one of the variables and plug it into the other. So with this system of equation, we have two lines graphed here. We have 4x minus 2y equals 9, and that'll look like something on our graph. We don't know what, but it'll look like something. We have negative y equals 4 minus 6x. That'll look like another thing. What we want to know is when those two meet. They're not the same line, so they're probably going to meet at some point. And we want to know when that happens. So first, let's get y all by itself. Y was negative. We don't want to deal with the negative y. Let's just simplify it down. So we have y equals now 6x minus 4. You just flip the order. Now that we know what y is, we can plug it into the previous equation, which will now give us 4x minus 2, 6x minus 4 equals 9. We just substituted the y into that first equation. From here we multiply across, commutative property, or distributive property. Then we just combine like terms. We subtract 8 from the one side, combine the 4x and the negative 12x. This should feel like review. We get negative 8x equals 1, which is the same as x equals negative 1/8. Now it's really easy to stop here and say we're done, but we're not. What do we still got to do?
Figure out y.
Figure out y. So we take what we know for our 8, negative 1/8, or for our x, it's negative 1/8, and we replace it into any of the equations. Now you can choose whatever equation you want. You can take this negative 1/8 and put it in for x here, 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 or here. Won't make a difference. You'll get the same answer. But if you want to save yourself time, just use the equation that you already solved for y, because that's what we're looking for now. So we can just plug negative 1/8 into that. You just multiply, you get negative 38/8, because our negative 4 is the same thing as negative 32/8, and then combine terms. So I skipped a little bit of a step there. But in the end, you get negative 38/8. So we can simplify that down once too. Our final solution then is the point negative 1/8, negative 4 3/4. So with those two graphs, however they're plotted on this grid, we still don't even know what it looks like. But we do know that they meet at negative 1/8, negative 4 3/4. Right here is where those two graphs will meet, which is pretty good to know. So now, Ian, I'm going to have you use a calculator to find this out, because we can do that by hand, and we'll get the right answer. But it can be a little bit time consuming, and if you have a calculator handy, there's some neat ways that you can save a lot of time.
What do you? Oh. Yeah.
There we go. Alright, so let's go ahead, clear out of that, go to a mode, make sure we're dealing in function, and then go to y equals. So on our y equals, let's punch in x squared, because that's one of our equations. And then for the other one, are we able to punch in x equals 2 minus y?
No.
No? Well, what can we do instead?
You can solve for y.
Solve for y, and what would we get then? Negative x plus 2. Nice job. So let's go ahead and hit graph. So now we'll see that we have a parabola, x squared, as well as a line of negative x plus 2. And this will intersect at 2 points. One of the points is up here, it's a little bit off the grid. The other point is right there.
We can fix that.
We can absolutely fix our window, make it look a little nicer.
Ian, where's your program for the window?
And there we go. Just like that. We now have a nice visualization of what's going on here. But jumping back to the substitution method. Now we see here that we have one equation solved for y and one equation solved for x. Which one do we think we're going to want to use?
Well, you got to get rid of this app.
I want to use the top.
What app?
The
There's
top
a
one is
goofy app that I
substituting in
hate.
the bottom.
Yeah.
So what would you get?
It comes installed, but we're just going to get rid of it.
X equals 2 minus x squared.
Which
Right.
one is it?
So if you
It's just
substitute in your
inequality
y
one,
equals
which
x
just
squared,
goofs
down here
everything
you'll
up.
get
This
x
one.
equals 2 minus x squared. And this is much better than going the other way. If you were to go the reverse direction, you would get y equals 2 minus y, the quantity, squared. And now you're just dealing with a whole mess of other stuff. You don't need to do it. Math's the pursuit of laziness. So find the easy way out. It's a lot easier substituting this way, just go with that option. So this we can rearrange to x squared plus x minus 2 equals 0. And now if we remember how to factor from algebra, we can go and factor it out to an x plus 2, x minus 1 equals 0. So for what x values should my intersections happen at?
-2 and 1.
Negative 2 and 1. And if we look at our graph, does that look about right?
Yeah.
Awesome. So yeah, let's hit trace and hit -2. Enter. And we get a y value of 4. Now I hit trace again. Hit 1. And we get a y value of 1. So let's see if the rest of the math checks out. We know that x will equal -2 and x will equal 1. So if we plug those back in to find our y values, using this first equation, if we plug -2 in, we get y equals 4, which is right. When x is -2, y was at 4. And when we're at 1, y equals 1. So just like that, we can use substitution to solve this. We can do it on our calculators as well to confirm and to
Well, here it
convince
is.
ourselves of it. So our 2 points would be -2, 4, and 1, 1. And those would be our solution.